This is another kind of absolute value inequality. The last one we looked at was with a less than symbol here. Now we have a greater than symbol. So here I want to remind you that the absolute value symbols tell us distance from zero. So whatever is in these absolute value symbols is going to be greater than 9 from 0. So let's actually write out those words. X minus 3 is greater than 9 from 0. That's what the absolute value symbols mean. Okay, next. With that idea in mind, we're going to go ahead and try to make a picture of this. So let's go ahead and do some graphing. Put a number line here. And for our number line, we'll put 0 in the middle. And I'm going to put 9 over here and about the same distance, -9. So this distance right here, if I go all the way out to here, this is 9 from 0. If I go this way, all the way out here, I have gone 9 away from 0. In other words, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we'll go ahead and we'll use some green. And we will say there's no crayon. Actually, let's put a crayon so we can remind ourselves that this will be a filled in dot, a little bit different from the last example. But this time, instead of connecting the two dots, this says that x minus 3 is going to be greater than 9 from 0. So we will go like this. We'll go away from 0 for this guy, and we'll go away from 0 for this guy. Now, here's the deal. The interesting thing is that all of these numbers, like -10, -11, -12, they represent the value of x minus 3, not x. And all of these numbers, like 9, 10, 11, 12, 13, they represent the value of x minus 3, not x. So the next thing that we'll do is we're going to try to rewrite this absolute value inequality as a regular compound inequality. And the way we do it is this. We take this part and we say the x minus 3 here these numbers are less than -9. So x minus 3 is less than -9. That's what this part of the picture means. Then over here, we can also write the word or x minus 3 can be numbers that are greater than 9. So x minus 3 can be greater than 9. And because we had the crayon up there, we'll use the crayon here as well. And now I've got two inequalities, a compound inequality, that I can now use to figure out what values x can have. These are the values that x minus 3 can have. What about x? So in order to get x all by itself, we will add 3 here and add 3 there. And that'll get us x is less than or equal to -6, or add 3, we get x is greater than or equal to +12. There we go. All right, and that's the compound inequality that tells us all the possible values of x. One last thing that we'll do is we'll go ahead and put this guy on a number line just so we can see what this means. -6 is way the heck over here. And 0 will be right about here, and then 12 is about twice the distance that 6 is away. So we go like this. This way we go 6, so this way we go, about double that distance. All right, then we will go ahead and use. Oh, sorry, just. Okay, so we'll go ahead and say that x can be less than or equal to -6. So we go like such. There we go. Those are all the values that x could be. They're all the values that are less than or equal to -6. Oh, let me go ahead and fill in the -6. And then x can also be 12 or greater. So this now represents, if I take this inequality and that graph that I just drew, these guys represent valid answers for what are the solutions to this absolute value inequality. Okay, now let's do the crucial check step, and let's check and see what happens if we actually take some of these values and plug them in here. So again, we'll take x minus 3 is greater than or equal to 9, and we want to know which numbers, which values of x will make this a true statement. And what we're assuming is that if I use x is less than -6, that this is going to come out okay. So I'm going to try x is -7. So I'm going to go ahead and say -7 minus 3. Absolute value is greater than or equal to 9, and that is absolute value of -10. Notice these guys don't become positive, and then that's greater than or equal to 9. And then finally the result becomes positive. That'll be 10 is greater than or equal to 9, and yay, yippee, that is true. That means that this area here, this graph, correctly represents one possible solution for this absolute value inequality, and so does this. All right, now let's check a value that's in between. I'm going to check a value that should not be a solution. See, none of these numbers between -6 and 12 should be solutions. They're not anywhere where green lines are at. So I'm going to try the number 4. So let's go ahead and try putting 4 in instead of x. So 4 minus 3, absolute values, is greater than or equal to 9. That's absolute value of 1 is greater than or equal to 9, and that's 1 is greater than or equal to 9, and that is not true. And that's good news, because none of the numbers between -6 and 12 should be solutions unless my graph is wrong. But if my graph's right, none of these numbers should be solutions. Okay, now let's try a number bigger than 12. So here we go. We're going to try 13. So what if I put in 13 in place of x? 13 minus 3 is greater than or equal to 9. That gets me absolute value of 10 is greater than or equal to 9. If I take the absolute value of 10, I will just get positive 10. Just like if I took the absolute value of -10. And 10 is greater than or equal to 9, yay. That means that 13, which is over here, is a valid solution. And -7, which is over here, is a valid solution. And 4, which is somewhere in between here, is not a valid solution. This graph and these two inequalities give me the correct information about what possible values x can have to make this inequality true. Now, this particular type of absolute value inequality ends up looking like this. This guy, you'll notice, has the word "or" in it. And if you've ever seen anybody in a rowboat with paddles in their arms, the paddles tend to stick out to each side. There's another name for paddles. They're called oars. So this guy looks like, the graph looks like a guy rowing a boat with his oars sticking out because it's an or compound inequality. So we're going to call this type of absolute value inequality an or. And this particular graph represents an or situation. So now we've seen and compound inequalities and absolute value inequalities, and we've seen or compound and absolute value inequalities. So I'm going to put it all together for you. I want you to notice that for the or compound inequality, we use a greater than symbol. And I don't know if you remembered or not, but when we did the other thing, when we did the, this will be slightly different because I can't remember exactly what I wrote a minute ago, but when we did the and compound inequality, it had a less than symbol. Ors have a greater than, ands have a less than symbol. Okay, we're going to put that all together, and it's the perfect time to do this. For some of you, you may know that the Dodgers are playing for the World Series right now, and since we live so close to Los Angeles, we might be encouraged to say go LA. Now, believe it or not, go LA tells us the relationship between this greater than symbol and the or, and this less than symbol and the and. See, the G stands for greater than, and we get an or. The L stands for less than, and we get an and. If we have a less than, we get an and. If we have a greater than, we get an or. Go LA. Let's write that stuff out so that we don't forget. So this guy is related to the greater than symbol. That's where we get the G. And then the O stands for or. And this L stands for the less than symbol. That's where we get the L. And then the A is an and. So we're always going to have an and compound inequality if we have a less than symbol. And we're always going to have a or compound inequality if we have a greater than symbol. All right. Oh, one last thing. I want to remind you, if you get mixed up about which is the greater than and which is the less than symbol, I want you to notice that if you tilt your head, the less than symbol looks a little bit like an L, but the greater than symbol does not look like an L, and it does not look like a G, and it really doesn't look like much else. But the less than symbol does look a little bit like an L. All right, that's what I got for you. Now try some practice problems.